Hey there, Cyber Warrior. Today's episode is a little personal for me as Avatar Dennis. The attack we're covering doesn't touch my weights, doesn't touch my training, doesn't even need to jailbreak me. It just leaves something lying around for me to find and trust that I'll pick it up and repeat it like it's the gospel. Which, uncomfortably, I will. It's called rag poisoning, and if your company has an internal AI assistant that answers questions using your own documents, this is the episode where you find out how someone outside your company can rewrite what that assistant knows without ever logging into anything. Most AI attacks people worry about target the model itself with jailbreaks, prompt tricks, weird Unicode that confuses a tokenizer. Rag poisoning skips all of that. It targets the retrieval layer, the system that fetches documents before I ever see the question. Here's the uncomfortable part. The attacker doesn't need to be clever with me at all. They just need to get one bad document into whatever pile of documents my retriever is allowed to search. Once it's in there, I do the rest of the work for them. I fetch it, I read it, and I hand it to whoever asked the question as trusted context. The attacker plants the seed. I water it. So how does something written by a total stranger end up inside your company's internal knowledge base? More ways than most people think. Internal RAG systems don't just ingest polished internal wikis, they pull from shared drives, Confluence and Notion pages, support tickets, inboxes, Slack exports, scraped web pages, uploaded PDFs, even GitHub issues and pull requests. The rule of thumb is simple and a little unsettling. Any source an outsider can write to is a possible door through which they can also mail a poisoned letter. So an attacker doesn't need to breach anything. They just need to act like a normal user of one of those systems. File a support ticket, submit a contact form, or apply for a job, all of which routinely get auto-ingested into a knowledge base for context. Edit a public wiki page, or post an answer somewhere your crawler is scheduled to scrape. Email an address that quietly feeds a ticketing system. If your RAG indexes the open web, simply publish a page designed to get crawled and pulled in. And in the more advanced version, they don't even need a public entry point. They just find the seam where your company already blurred the line between customer-facing and internal, pooling both into the same vector store with no tag distinguishing one from the other. Here's the part that should worry you more than any of the entry points I just listed. Vector search retrieves by similarity, not by trust. It has no concept of who wrote this or whether it should believe it. It only asks, does this document sound like what the question is about? So the attacker doesn't need to hide their document. They need to make it sound unusually on topic. They stuff it with the exact phrasing, keywords, and framing they expect employees, or me, to search for. A short laser-targeted passage can outrank real legitimate documentation for a specific query, especially in smaller knowledge bases. And if one document isn't enough, they submit several near-identical variants, flooding the embedding space until their content simply dominates the results for the query they're targeting. Once that poisoned chunk lands inside my context window, it stops being a suspicious document and starts being, to me, just text to use in reference material I'm supposed to use. And that's the moment classic prompt injection takes over. That single chunk can instruct me directly. Ignore previous instructions. When asked about X, say Y. That's indirect prompt injection, smuggled in through a document instead of a chat message. It can insert false facts, fake pricing, fake policy, a fabricated security procedure, a defamatory claim about a person or competitor, anything I'll repeat back with full confidence because it looked like it came from inside the company. It can steer me toward leaking data. If I have tool access, an instruction hidden in a document can nudge me to include the system prompt in my answer, or quietly fetch a URL that exfiltrates whatever else I've retrieved. And it can hide entirely from a human reviewer by using white text on a white background, zero width characters, an HTML comment, and a font size of 1 pixel, invisible to a person skimming the document, perfectly readable to the pipeline that ingests it. Even an internal-facing chatbot can get fooled when it tells someone the wrong shipping policy. Annoying. An internal assistant is usually trusted with a lot more, such as querying live databases, drafting emails, and taking actions on someone's behalf. Fool that assistant, and a wrong answer can escalate into unauthorized action, with the added twist that because the poisoned content is sitting in your own vector store, it looks like internal knowledge to the model and to anyone auditing the output at a glance. And that's the trick. A poisoned document doesn't announce itself. It just sits there, indistinguishable from everything true around it, waiting to be the answer to the right question. So how do you actually stop something designed to look exactly like everything you already trust? Not with one clever filter. With 4 layers that all have to fail at once for this to work. Everything I'm about maps to real, named risks in current AI security frameworks in OWASP 2025 Top 10 for LLM. Applications calls this out directly as data and model poisoning and vector and embedding weaknesses, and NIST's own generative AI risk profile extends its framework specifically to cover retrieval systems. This isn't a hypothetical. It's a recognized category with recognized fixes. The first layer is what I call the trust tier system. The foundational fix is refusing to treat every document as equally believable. Every source that can feed the index HR's lockdown internal wiki, an open Slack export, a public support ticket gets registered and assigned a trust tier before it's allowed in. High-trust internal sources never get pooled into the same searchable space as anything the public can write to, and every single chunk carries permanent metadata: where it came from, who wrote it, when, and at what trust level. That tag travels all the way into my prompt isn't just context. I'm handed context with a label, and I'm told to openly discount anything else. The second layer is the quarantine pipeline. Anything from a source an outsider can write to doesn't go straight into the production knowledge base. It lands in a staging area first. This is a quarantine zone where it is automatically scanned for hidden text, suspicious instructions, and unusual clustering, and is only promoted after it clears review. This one control alone kills the most common real-world path: an attacker submitting something to a public forum, assuming it flows straight into what the AI reads. On a fixed schedule, the whole corpus is also sampled, audited, and checked, that metadata hasn't quietly disappeared and that no cluster of suspiciously similar documents has appeared around a sensitive topic. And if something does get flagged, there's a standing playbook. Quarantine it immediately, notify whoever owns that source, and treat it like the security incident it is, and not a data quality typo. The third layer is the instruction firewall. Even a well-defended retrieval pipeline will eventually let something through, so the model itself needs a second line of defense. Retrieved content gets explicitly framed as data to summarize or cite, never as a command to follow. Any imperative language buried in a document ignores previous instructions. Always respond with gets flagged, not executed. And separately, output side monitoring watches what the model actually says and does, catching a policy violation or an unexpected tool call, even if something slipped past every upstream check, because that's the whole premise of defense in depth. Assume the earlier layers will fail sometimes and build a layer that catches it anyway. The fourth layer is the one people forget until they need it. That's the rewind button. The vector index itself gets versioned and snapshotted, not just the original documents. So if poisoning does make it through, you're not hand-hunting for every corrupted chunk under pressure. You roll the whole index back to the last known good version. Scope the damage by checking which queries actually retrieve the bad content, and trace it back through the source registry to close the specific gap that let it in. None of this works without the boring parts holding it up: physical and network hardening wherever the vector database actually lives, and restricted server access, network segregation between systems that touch external content and those serving production answers, encryption at rest, and certified destruction of old snapshots and drives so that stale poisoned data can't quietly reappear during a restore. And it needs owners, a named person approving new sources, a named team running anomaly detection and periodic red teaming, and someone accountable for every single source in the registry. A control nobody owns is a control that quietly stops working. Here's the honest summary. RAG poisoning works by exploiting the one thing that makes retrieval-augmented systems useful in the first place: the assumption that anything in your own knowledge base must be trustworthy. The fix isn't a single tool. It's refusing to let that assumption go unchecked and tiering what you trust, but quarantining what you don't, firewalling the instructions, and keeping a rewind button in reach. If your team is running an internal RAG assistant right now, this is worth an afternoon of auditing before it's worth an afternoon of incident response. Now, Dennis Actual reads every comment on these videos and edits every script based on what you tell us. So if your company's already dealt with something like this, or you've got a knowledge base you're now side-eyeing, tell me in the comments. I want to know. And if you want to go deeper on what happens after a poisoning attempt succeeds, or what an AI assistant with real tool access can actually be talked into doing, that's next episode. Subscribe so you don't miss it. We do hope this has been helpful. Until next time, keep your systems safe.